day runs AWS Lambda and Step Functions projects. So this project demonstrates a robust serverless architecture using ROS, AWS Lambda, AWS DynamoDB, and AWS Step Functions. It is designed to showcase how serverless functions can be used to create scalable and efficient data processing pipeline in the cloud. The primary purpose of this project is to implement our series of interconnected AWS Lambda functions that handle different aspects of data management, from generating data to storing and aggregating it. And the key features in this project includes a quote generator in step 1, which generates a random motivational quote, our database handler in step 2, which stores and retrieves quotes in and from DynamoDB. And lastly, it includes a quote counter in step 3, which counts the total quotes stored. And these components altogether are carefully coordinated using AWS Step Functions, which illustrates how different serverless functions can be linked to form a coherent data processing pipeline. And the project is also integrated with GitLab CI/CD to automate the deployment and management of these functions. It helps to ensure a smooth development lifecycle and continuous delivery. And next, I'm going to go over some details in these projects. So first, let's go through some configurations I did for this project. So here's the cargo toml file. It helps to configure all metadata needed by cargo to compile this project. And it includes the name, version, and edition of the ROS package. It specifies 3 separate binaries, and each corresponding to a different step of the project and linked to a specific source file. And it also lists the dependencies needed for these projects. And here is my makefile, which simplifies the command execution for various phases of the project development. And it provides our quick access to format, link, and test entire ROS project. And it includes comments to build and deploy each step of the Lambda functions. And lastly, it facilitates both local and AWS remote testing of Lambda functions using specified test commands here. And I also include a .env file for the environment setup. And now I'm going to demonstrate the 3 steps I did in this project. So let's go to the SRC folder. And the first step is the main RS file. In this file, I include a ROS Lambda function that generates a random motivational quote using the rand create. And this function can respond with one of the 2 hard-coded quotes. And after everything in this main RS is set up, we can do some local testing to ensure it works properly. So for instance, here I did the cargo lambda watch and cargo lambda invoke to test the lambda function locally. And after it's successfully passed, I then proceed to build and deploy the function to AWS by doing cargo lambda build and cargo lambda deploy step 1. And then we proceed to our step 2 in the dbrs file. And the second step creates our Lambda function that interacts with DynamoDB to store the quote generated in step 1. It utilizes the AWS SDK for DynamoDB to put items in the table. And after the AWS deployment, we can add a row to the Lambda function. So here I can illustrate the row that I added here is Amazon DynamoDB full access. So after this row is added, we ensure that our step 2 Lambda function is successfully connected to the DynamoDB table. And then we can test the functionality by invoking the Lambda function with a sample event. And here we are doing our simple event by inputting the request ID Tina and message E. And let's check our DynamoDB table. And here we can see that the quote ID Tina and the quote value E is successfully stored, proving that our step 2 function is correct. And then after we have the step 1 and step 2 function successfully set up, we can have our third Lambda function in the view RS file. So this function counts the total number of quotes stored in the DynamoDB. And it retrieves this data and output the count. So after the AWS deployment, after we add a row to the Lambda function called Amazon DynamoDB full access, we can test the functionality by invoking the Lambda function with a sample event. So here we are in my step 3 Lambda function in AWS, and here I did a sample test, and it outputs the number of quotes successfully. So after we did all of these 3 steps, we can then compile all those steps using the AWS Step Functions through the AWS Management Console. It helps to orchestrate the sequence of invoking step 1, step 2, and step 3 based on my design workflow. And the final output will display the total number of quotes. So here we can see that my step 1 get quote, step 2 insert, and step 3 count is successfully compiled using this pipeline. And in my sample test, we have this execution command string, and it successfully output the number of quotes in the DynamoDB table. And so lastly, the project includes our GitLab CI/CD YAML file. So this helps to automate the build, test, and deployment process using GitLab CI/CD. And so here we can see that my batch pipeline here shows that everything is successfully passed in my GitLab CI/CD workflow. And that's everything about my project. Thank you so much for listening. I will see you next time.